Now I am going to explain AC voltmeters. At the end of the session, you will be able to understand the operation of AC voltmeters and know the different types of AC voltmeters. We have different types of AC meters. So first of all, what is AC voltmeters, which is the instrument which is used to measure the AC voltage across any 2 points of an electric circuit is calling as a AC voltmeter. If the AC voltmeter consisting of a rectifier, then it is said to be rectifier based AC voltmeter. The DC voltmeters measures DC voltages. If we want to measure AC voltages with the help of the DC voltmeter, then we have to follow two major steps. The first one is convert the AC voltage signal into the DC voltage signal by using a rectifier. And step two is measure the DC or average value of their rectifier's output signal. This is the instrument of AC voltmeter. This is the scale. This will also follow the D'Arsonval principle. Okay, so this is the scale. If you apply the current through to the coil, we have a coil. Here the coil is placed in between the two magnets, permanent magnets. And when we apply a current, when we connect two terminals of a voltmeter to the circuit in parallel, the current will be flown through the coil. Based on the applied current, the scale will be moved. Why? Because this pointer is not scale. The pointer will be moved from 0 to 250 volts based on the applied current. And we are connecting one resistance also to limit the current. Right? Suppose by using a DC voltmeter, we can measure AC voltage with the help of the rectifiers. First of all, we convert the AC signals into DC. Right. This is the block diagram of AC voltmeter. Here we are applying AC voltage to be measured. Here the attenuator is used to control the input voltage. Then here we are using a rectifier. This rectifier will convert the AC signal into DC. And also here we are using a multi-stage DC amplifier. Multi-stage DC amplifier to amplify this signal, and we are connecting this one to the permanent magnetic moving coil. Right. This is the one more type of AC voltmeter. First of all, here we are connecting a attenuator, then amplifying that signal and rectify it. Then it will be given to the permanent moving coil instrument. In electronic AC voltmeters, input signal is firstly rectified and then supplied to the DC amplifier in the first case. In the second case, sometimes the signal is firstly amplified by the AC amplifier. This is the second case. And then we can rectify and give it to the permanent moving magnetic coil. Okay. Based on that, we have different types of AC voltmeters. That is rectifier based AC voltmeter. In the rectifier based AC voltmeters, you have two types. One is AC voltmeter using half wave rectifier and AC voltmeter using full wave rectifier. As we know in the EDC, what is the advantages and the disadvantages of half wave rectifier, and what are the advantages and disadvantages of full wave rectifier. Compared to these two, the full wave rectifier AC voltmeter will be the better one. And one more is average reading AC voltmeter and peak reading AC voltmeter. This circuit is half wave rectified type AC voltmeter. This will be the full wave type rectified type AC voltmeter. Here we are using a bridge circuit as a full wave rectifier. Here we are using a one diode. The AC input signal is given to the diode. This AC is converted into the DC. Already we have a galvanometer, that is the PMMC instrument. This instrument is connected in series with the RSH. The current will be controlled by the RSH, and the signal is converted into the DC. Like that, the AC voltmeter using half wave rectifier can be designed. In case of full wave rectifier, Here we are using a multiple resistance, multiplier resistance. Multiplier resistance means this is the combination of number of resistance. Here we are using a switch actually. Okay. Suppose we use a single AC voltmeter, single resistance is sufficient. Okay. Here we are applying input alternating current here. Okay. If you apply the alternating current, if that current will be controlled by the multiplier, that will be acting like a attenuator. Already we have seen in the previous block diagram. This will be acting like a rectifier to convert the AC signal into the DC, and then we connect it to the PMMC instrument. So totally it will be acting as a AC voltmeter. These are some basic standards. That is the SDC is equals to 1 by IFSD, and peak voltage is equals to 1.414 into RMS value. DC voltage is equals to 0.45 into ERMS value. Suppose we want to calculate the RS value, SDC into EDC minus RF. Like that, we can finding out the resistance, how much signal should be attenuated to control the scale on the screen, right? The one more type is multi-range AC voltmeter. Like previously we have discussed multi-range DC voltmeter, right? In the multi-range DC voltmeter, here we are not using any diodes. Okay. In case of multi-range AC meter, we are using a diode for like a rectifying circuit. Okay. This RSH and RM will be acting like a voltmeter. Right. Here we have different ranges. This is the AC input signal. Suppose we want to calculate the reading between 0 to 2.5 volt, the switch should be connected to the 2.5 volt range. Then this R5 will decides the value of the range of the voltmeter. Suppose we want to design 0 to 10 volt, then this switch is connected to this point. This switch is connected to this point. Then R4 and R5 decides the range of the value of that voltage. And if you connect this switch to 50 volt, R3, R4 and R5 will be the deciding factors. Right. Here I have written the RHS is the meter shunt and acts to improve the rectifier operation on 2.5 volt range. R5 acts as a multiplier to the this current value, this current into this resistance, that will give the this range of that value 2.5 volts. If you connect R4, the combination of these two resistance into this one will give the this range. If you want to get a 50 volt range, this resistance into this current will indicate 50 volt. Maximum value will be the 50 volt. Like that, we can design a multi-range AC voltmeter. This is a multi-range AC voltmeter. Therefore, here we have a different ranges. If you rotate this knob, this will be connected different ranges. This will be a switch. It will be acting as a switch like this. If you rotate this one, if it is connected to this point, this will be 1 volt. The range will be 0 to 1 volt. If you connect, if you set this knob to the 10 volt, it will be acting like a 0 to 10. Based on that, the indicator will be shown. The one more is average responding voltmeter. Okay, average responding voltmeter. The input waveform is amplified using a stabilized amplifier to a high level and then rectified and fed to the DC milliamps meter, calibrated in terms of the RMS input voltage. Actually, here we are applying the input voltage. Here we have the different ranges. This is a switch. This is a switch is connected for different ranges. Point one, V1 is one range, V2 is one range, V3 is one range, V4 is one range, V5 is one range. Input is connected to the blocking capacitor to block the DC signal. Okay, here we are using a switch and high gain stabilized amplifier. Here we are using to get the high signal, and the diodes, these two diodes will be acting as a rectifiers, and these two capacitors will acting as a coupling capacitors or feedback capacitors. And actually we are applying the AC signal. That's why it controls the harmonics of a signal. Here we are using a galvanometer. Okay. So the capacitors in the meter circuit tend to act as a storage or filter capacitors for the rectifier diodes, as well as a coupling capacitors for the feedback signal. Diodes acts as a switches to maintain unidirectional meter. A rectified circuit is averaged by a filter to produce a steady deflection of the meter pointer. DC component blocked by the blocking capacitor. This. So actually we are applying the AC signal. If you apply the AC signal, the scale will be moves positive and negative, front and back. Some deflection will be occurred. That's why here we are using the two diodes. One diode is connecting for positive peak, and another diode is connecting for negative peak. That like that we can stop the deflection of the scale also. And AC amplifier have negative feedback, which ensure gain stability of the measurement, accuracy, and increased frequency range of the instrument also. Okay. So by using the feedback, we can improving the stability of the system. Here, from this point to this point, we are giving the feedback to the amplifier, like a feedback amplifiers. Improves the accuracy as well as the stability of that system. Why? Because it is a high gain amplifier. Here we use it, operational amplifier. Okay. The basic difference between the peak responding voltmeters and average responding voltmeters is the use of the storage capacitors with the rectifying diodes in former case compared to the previous circuit, that is average responding voltmeter. In peak responding voltmeter, we are not using two diodes or two capacitors in the form of a bridge. Okay, only simply we are using single diode and a single capacitor. For AC signal, the capacitor will be charged. Okay, this capacitor charging will be based on the DC amplifier. See this one. The capacitor charges through the diode to the peak value of the applied voltage, and the meter circuit then responds to the capacitor voltage. The two most common type of peak responding voltmeters are given below. This one and one more figure is there. Figure A, this one shows a DC coupled peak voltmeter in which the capacitor charges to the total peak voltage above ground reference. In this case, the meter reading will be affected by the presence of the DC with the AC voltage. Why? Because here AC will be stored as well as a DC we are getting after the diode also. Okay. So the second one is an AC coupled peak voltmeter is shown in circuit. That is replace the diode with capacitor and replace the capacitor with the diode. AC is DC is directly applied. AC will be stored by the capacitor. Maximum AC signal will be opposed by the capacitor also. Right. In both the circuit, the capacitor discharges very slowly through the high impedance input of the DC amplifier. Based on this one, it is having high impedance circuit. Why? Because op amp is a high gain amplifier. That's why it is having high input impedance. Based on that high input impedance, it will be discharged slowly. So that the negligible small amount of current supplied by the circuit under test keeps the capacitor charged to the peak AC voltage. The DC amplifier is used in the peak responding meter to develop the necessary meter current. The primary advantage of a peak responding voltmeter is that rectifying diodes and the storage capacitors may be taken out of the instrument and placed in the probe when an AC amplification is required. Replacing this one, we can measure the AC voltage also. The disadvantage of the peak responding voltmeter is the error caused by the harmonic distortions in the input waveforms. That is AC waveforms. That's why the harmonic distortions will be occurred. In case of peak in case of average responding voltmeter, here we are using a diode. The type of harmonic distortions will not be occurred. These are some of glossaries. What is a rectifier? Rectifier is a device which converts the AC signal into the DC signal. Attenuator. It is used to reduce the amplitude of the signal. The next topic is ammeters. The sample short answer questions is explain how the range of AC voltmeter is extended. Sample long answer is describe the long answer question is describe the working of a rectifier based AC voltmeter with neat diagrams. Explain the operation of peak responding voltmeter with neat diagrams. Thank you.